Hello, my name is Tua Chaw. I am an account manager for Lakos filtration here in Fresno, California. I service the groundwater and irrigation markets. And today I want to talk a little bit about pump protectors. Well, specifically turbine pump protectors. Now, Lakos does make submersible pump protectors as well, but for today I want to focus primarily on the turbine pumps. Okay. Now, fun fact, this is actually the oldest running product line that Lakos carries. This is the very first product ever produced by Lakos Filtration. One, sand kills pumps, and two, pumps are expensive. So going back to number one, if you are able to remove the sand effectively prior to it getting into your pump, you essentially solve number two as well. Oftentimes pumps are about 3 times or more expensive than a pump protector separator. PPS installed on a pump can actually extend the life of the pump for up to 4 times. So having a PPS installed is almost a no-brainer. That being said, when would you want to use a PPS? PPSs are, in my experience, they've typically been installed in 2 applications. Application 1 is underdeveloped wells. For the underdeveloped wells, especially now in this day and age, everybody wants something right away, immediately, yesterday. And because of that, well, if you put a PPS, chances are that well, that downtime that it takes for that well to develop probably won't last as long. You can probably run something right away with that. On the opposite end of that spectrum, you got very old wells. Well, very old wells tend to pass sand a little more. Either the gravel pack's not as good anymore, or the liners have gone away, and you either need to re-drill a well or you need to reline it. Something that requires a significant amount of investment. So sizing out PPS is pretty simple. Lakos usually sends out a LS 423 with every single purchase. So if you don't have one, chances are there's some aspects of your warranty that may be affected because Lakos won't be able to verify the application works. One of the most important factors on these is going to be the flow. So flow rate, maximum flow rate is typically what we look at. Your minimum flow rate is not too important to us currently, only because the minimum flow rate doesn't do anything to actually damage the separator or your pump for that matter. The maximum does. It can actually damage your separator if the velocity is too high. It can tear that separator apart. The next factor is going to be the well ID. Well ID, again, goes back with velocity. Sometimes nowadays the pumps are getting so efficient. Pumps are more efficient now. Smaller pumps are being able to crank out more water than older pumps that can do. And so with that being said, if a smaller pump fits into a smaller well and still pumps out quite a bit of water, we still can't put a separator in there. So just knowing that the well ID is going to be adequate for us to put a pump protection separator in there, that's the importance of knowing the well ID. Next is going to be submergence. Obviously, submergence is important. We don't want your pump sucking up air. It's got to be pumping water. The typical well depth and pumping water level is known. Even if you haven't really drilled it yet, you'll already have an idea of where the water level is going to be and an idea of how deep you need to drill the well. So that being said, let's focus on what we can do in terms of being able to help with the pump setting. So the pump setting is not as important as being able to let you know where you can set the pump. So we know that Lakos suggests at least 20 feet below the separator. And then we also know that depending on the model, you need at least 30 or 60 feet of submergence. So that being said, if we take into account the depth of the well, we subtract the depth, the pump setting, or we subtract the PPS length, well, it'll give us exactly how many feet you need to go to the bottom of the well. From there, it's easy for us to dictate or for us to recommend to a customer where to set the pump setting in order for them to be able to use a PPS separator. PPS separators now, going back there, we have 2 types of PPS separators. With Lakos, there's a single letter suffix and a triple letter suffix separator. The single letter suffix, as here pictured in this slide, you'll notice that there has 3 flow collars: off, B, and A. All right, so the off usually comes with the highest flow. The B is the middle, and the A is the minimum. So important fact here, and important for you guys to also know to know, is that sometimes you need to check this. Usually with Lakos, it will come in the collar off position, but sometimes it may not. And then depending on what your application calls for, you'll have to switch that collar onto a certain setting. So if your application calls for a flow between 525 and 650, but the collar is set to 325 to 425, make sure before it's installed, you put it onto 525 to 650. If you don't, it's going to run up to this right here only, and your maximum flow is going to overflow this capability and can potentially damage the separator. Purging options, option number 1 and standard comes with every single separator is the flapper valve. So the flapper valve, the positives about this is that it's a very small unit. It's a complete unit, so you don't need to buy or add anything else to complete it. And right here to estimate from here to the bottom of the well, very simple. It just attaches to the end of the separator. The downside of this is that it is a moving part. So because it's a moving part, it's going to wear over time and you will need to replace it. The other thing is going to be installation. Make sure that when you install it, it comes in with you. The crease here must be installed perpendicular to this cross that's located at the bottom of the purge outlet on the separator. If it's not installed perpendicular, what could initially happen is that when the pump is pumping at full bore or prolonged, this flapper can actually get sucked up into the separator. When that happens, it goes inverted, and eventually what it would happen is that you won't be able to purge. Nothing will be released out, and then your separator is going to pass sand. The other option is going to be the tailpipe. So the tailpipe replaces the flapper valve. Notice here, it replaces the flapper valve if you are running a different application, or if you're running a application that means that you're going to be running, in a sense, full time. If you're going to be running 24/7 for 6-7 days a week, or 8 days a week, or continuously for a very long prolonged period of time, you want to run a PPS tailpipe. Reason being is that with a flapper, the way that it needs to work is that it has to relax in order for it to open up and allow sediment to pass through. With the tailpipe, it's a continuous purge. It's going to allow sediment to slowly pass through this pipe and drop down at a location far enough below the separator that it's not going to get repicked up by the inlet. With that being done, the downsides of this is that it's a very large unit. Very large units mean that when you calculate that 20 feet below the separator, it must be calculated at the tip of the tailpipe, not up here at the bottom of the separator. It's calculated at the bottom of the tailpipe. So a lot of times you don't have that space there as well. Okay? Last question, what happens to the sand? So according to a study published in the 1985 October issue of Water Well Journal, the sand is usually accumulated at the bottom of the well. This creates an inner sand gravel pack and slightly changes the flow characteristics. So usually over time it reaches a new equilibrium, and that keeps excessive sand from entering the well. Groundwater can flow and move sand back in and out of the well at the same time. So what that usually means is that your well shouldn't be adding any new sand in. That sand that is being pulled is already pre-existing inside of your well. The separator is simply just dispersing it at a different location. I don't think it's ever happened. Again, this is the very first separator that was ever built by Lakos back in early 1970s. So I don't recall any one single case that a well has actually been filled and would need to bail it out. But when or if it ever does, keep in mind, bailing a well is still much more cost effective than to actually replace or repair that entire pump or well. And thank you for listening. And those that stayed till the end, this is your promotional code. GWQ2 is for 5% discount off of all PPSs going on to the end of April. Okay? If you have any questions, feel free to give me an email or give me a call. Thank you.